Hello, everyone. I'm Paul Musto from Siemens Digital Industries, and I'm joined today with my co-host Tucker Marion from Northeastern University. Welcome to our Siemens Startup Podcast, where we dive into the journeys of groundbreaking startups that are reshaping industries and cutting-edge innovation.
I'm Tucker Marion. I'm a professor at Northeastern University, both in entrepreneurship and innovation, and also mechanical and industrial engineering. It's a pleasure to be here.
Excellent. Thank you, Tucker. And I am extremely pleased to be able to introduce you to Tim Berry from JetZero. He is our guest today, and we're very much looking forward to our conversation. Tim, you want to tell us a little bit about yourself?
Yeah, absolutely. And thank you so much for having me. Really excited to have a conversation with you today. By the way, my discussion may be punctuated by some aircraft taking off here because JetZero is located at the Long Beach airport. So please be patient with me. It kind of comes with the role of working at an aircraft company. So my name's Tim Berry. I have about 15 years of experience in the aerospace and defense business. I've worked at a couple notable startups like SpaceX, which is not quite a startup anymore, in a multitude of roles there, leading the Dragon 2 crew and cargo integration team, the Falcon 9 upper stage team, and overseeing the additive manufacturing lab, which is the largest in the world by mass. I also spent time as the vice president of manufacturing, supply chain, and quality at a space station company called VAST, building the Haven 1 commercial space station prototype. And then, as my coworkers like to remind me, I am now an airplane guy. So been at JetZero now over a year, and I manage our manufacturing, quality, and integration teams, both for our demonstrator program and for our production aircraft program as well. So great to be here.
Thank you very much, Tim. Maybe we can start by talking a little bit about JetZero and their goals and achievements.
Absolutely. So JetZero's mission is to reshape aviation, and we mean that quite literally. So the different technology that we're offering in comparison to what we would refer to as tube and wing aircraft that everybody's accustomed to and flying on today is a innovative design known as a blended wing body. So it's not a flying wing like a B-2 bomber. It's not a delta wing. It's somewhere in between where we have nominal outboard wings that blend into the fuselage. And the main selling point there is that it's about 30% more efficient for lift over drag aerodynamic performance, which translates into up to 50% more fuel efficient with comparable sized aircraft that are available in the market today. So really the company's mission centers on commercial aircraft program. We have a military contract that we've been working for the Air Force to build a demonstrator prototype in partnership with Northrop Grumman. And our aim is to deliver this game-changing efficiency to the commercial market as well, because we really haven't seen a lot of innovation over the past 60 years. You know, in the first 60 years of aviation, from the Wright Flyer all the way up to the first 737 model that was produced, there was an immense amount of innovation, different shapes of aircraft, different types of propulsion. And then since that time in the 1960s, really most of the efficiency and innovation has been centered on engine technology. So we're actually taking a look at the shape of the aircraft that can enable a massive reduction in fuel burn, which translate to a lot of operational benefits and cost benefits for anyone that uses this aircraft, and also comes with the reduction of carbon emissions as well. So really excited to be here and have the opportunity to deliver a new product and a new experience to customers as well. I think anybody that flies in commercial air transport today has some issues and some challenges with it. So I think this is a really big opportunity for the industry overall to change the experience, the operations, the efficiency, and really bring this new technology to bear for the commercial and military markets as well.
Can you talk a little bit more about that blended wing body for the layman out there who may not be familiar with airframe technology?
Yes, absolutely. So our founders, particularly our CTO, Mark Page, has been working on this since the 1980s when they were at McDonnell Douglas. And effectively, all we're changing really is the shape of the aircraft, right? So we like to refer to it as home plate shaped center fuselage. And then the wings, as you get out towards the tips of the wings, are more of a nominal shape comparable to what you would see in today's tube and wing aircraft. And because the entire fuselage is a lifting body, instead of on a tube and wing aircraft, basically the tube is all drag, the wings are really what are providing the primary lift. On a blended wing, the fuselage itself is also delivering a fair amount of lift to the aircraft, which ultimately allows us to use smaller engines than would be required of a similarly sized aircraft in the market today, which burn less fuel naturally. And then also because we have so much better or more preferable lift to drag ratio, it allows us to fly more efficiently with less drag and burn less fuel overall as well. It also offers a lot of passenger and cabin benefits. more comfortable experience, more space, more volume, and really the opportunity for airlines to paint on a new canvas, conversely to what they've been dealing with, over the past approximately 60 years.
Question for you, Tim. The size that Jet Zero is going to, the sweet spot of aircraft size, let's say in terms of capacity of people, where's your sweet spot, do you think, in terms of aircraft size?
So this is a mid-market aircraft. Because it's so efficient, we like to say it can punch above and below its weight, but primarily targeting the mid-market, which is about 200 to 250 passengers within the cabin. We have opportunities to flex up and down based on how much premium seating or economy seating, so on and so forth, but really targeting the mid-market, which doesn't have any active aircraft in production today to service it, right? The Boeing 757, 767 are no longer being produced, at least for the commercial air transport market. So we have a really great opportunity in what we refer to in the industry refers to as the mid-market gap to deliver this aircraft and support a lot of those routes that are being covered by less efficient aircraft today.
You alluded to it earlier, but the concept of a blended wing air body is not necessarily new, and it's just coming to fruition today. And what have been some of the challenges or barriers along the way to prevent it from becoming a technology, a mainstream technology before this?
I mean, NASA, over the years, NASA's invested about $1 billion into the BWB concept, the development of it. There was a couple subscale models that were made by NASA called the X-48B and X-48C, one of the most successful X-plane programs in history. What we see is that the key challenges that have prevented the adoption of BWB so far is kind of a combination of the innovator's dilemma. So I have this product that I'm delivering if I'm an OEM today, and I have sometimes on the order of $400 billion to $1 trillion backlog of those aircraft. So I'm really not incentivized to innovate and come up with this new product and invest into it because I already have such a backlog of the aircraft that I'm already delivering today. In addition to that, there's some aspects as well of capital investment and retooling of all facilities that are currently producing aircraft. So Jet Zero is well positioned to deliver this new product and technology to the market because we don't have that historical baggage, and also we don't have a backlog of aircraft that we still have to deliver. So we really have an opportunity now as the mid-market is open and we're a fresh company with a sole focus on this technology to deliver this new product to the market, whereas some of the other OEMs are still working through their own backlogs or may not want to make the capital investment at this current point to retool their existing factories.
Is the Stealth Fighter a variant of a blended wing body?
We would refer to as the Stealth Bomber or the Stealth Fighter as a flying wing. So the difference being here that on those aircraft, the triangular shaped fuselage effectively goes all the way out to the wingtips. But on a blended wing, you have nominal outboard wings that blend into the fuselage. So it's kind of a combination of a flying wing and a traditional tube and wing aircraft.
Well, a little pop culture reference for you and I, Paul, from our generation is in the $6 Million Man, they were flying a lifting body aircraft. Some of the early tests in the late 60s for alternatives for the space shuttle were lifting bodies, which ultimately have morphed into blended wing body, which is kind of a little historical fun reference.
Did not know that. It was one of my favorite TV shows when I was growing up.
I missed that one.
But in terms of technical challenges, the tube aircraft's very good rigidly, right, for compression and decompression. What kind of technical solutions is Jet Zero bringing to the table where it's solving some of the issues with rigidity and those issues of compression, decompression, which is within the fuselage?
The key challenge of the BWB is really centered on the cabin or the center fuselage. The outboard wings, the nose, and the aft section can all follow a nominal construction. But the core challenge is really in the center body of the aircraft. It's mostly related to the pressurization of the cabin itself, because in a tube, you effectively have really even pressure distribution on the inside of the aircraft onto the fuselage. But in a blended wing aircraft, it's effectively a non-cylindrical pressure vessel. That's both a challenge and an opportunity, right? Because in a tube and wing aircraft, if I want to make the aisles a little bit bigger or the seats a little bit bigger, what have you, the entire tube cross-section grows as a result of that, which adds mass, adds drag, so on and so forth. In a BWB, we can upsize and downsize the aircraft in the future more readily because it is, effectively a rectangular cross-section. But that does bring some challenges with pressurization and stress on the airframe itself. Technology that we're leveraging in order to solve this challenge was originally developed by NASA under the Perseus program, PRS-EUS, which stands for Protruded Rod Stitched Efficient Unitized Structure. We're drawing a lot from that project in terms of what we refer to as stitched resin infused composites, whereby you're taking composites manufactured starting in the dry state, so not using prepreg materials, and you're basically stitching through the layers of the carbon fiber in the dry state, both as a fastening mechanism, so taking the stringers, frames, keels, so on and so forth, and stitching those to the skin in the dry state, and then infusing them using resin transfer molding. But also it adds interlaminar strength as well, and adds an adequate damage arrestment feature, which was demonstrated and proven on the Perseus project when NASA actually built a full-size cross-section of a BWB and tested it to failure in their Colts facility. So using stitched resin-infused composites is really a key enabler for us to be able to deal with the pressure loading and what we would say is bidirectional loading of a BWB center body from pressurization. This also has added benefits beyond just, solving the non-cylindrical pressure vessel problem, because in today's aircraft market, even folks that are using advanced composites and they go through all the trouble of designing, qualifying, and building wings or fuselage sections out of composites, they then just proceed to treat it like black aluminum and shoot a million fasteners through it anyways. So we're actually trying to leverage composites for what they're good for beyond just solving the BWB non-cylindrical pressure vessel challenge. We are going to use composites to produce very large unitized structures, which not only have a lot of strength and rigidity and are lighter weight than what's used in today's aircraft, but also provide adequate damage tolerance and allow us to have a lot less of the kind of fitment and fastening issues that currently plague today's aircraft OEMs.
How about the passenger experience? Is it going to be different than a tube and wing craft?
Yes, absolutely. I mean, we have an airline working group with most of the world's largest airlines in it that are providing us regular feedback on different portions of the cabin and the experience, the layout, so on and so forth, requirements. Our cabin team is I would say second to none in the world. They come from a lot of established OEMs, and what made them join JetZero ultimately was this new opportunity, right? They've been fighting for inches or centimeters in the cabin or making very small tweaks over the years to try to improve the passenger experience. But this is really the first opportunity that they had and that the airlines have of reimagining the airline experience for the passengers in the aircraft itself. So if you just look at a BWB, on Google Images or on our website, you'll see that there is a considerable amount more volume. So it allows us to have better seats, more space for customers to move around. What we like to say is right-sized human spaces as well, not necessarily just cramming people into tiny little seats or forcing the flight crews to work in, what is effectively like a very small box at the front and back of the plane with a restroom that's adjacent to it. So we're really reimagining the entirety of the cabin layout, how customers interact with the cabin, and the opportunity that we have with this additional space to create just a more comfortable boutique experience for customers, which we feel will ultimately help to improve the overall experience of the flying public and take a lot of the stress off of flight crews today who kind of have to act as police people and deal with customers that are maybe less than happy. So it's a really great opportunity for us to improve the experience overall for the flying public. And, we like to say that when you come here and you see our full-size cabin mock-up and take a tour of it, that it may, unfortunately, ruin your flight home because you'll just be waiting to fly on this plane in the future. So it's a really great opportunity. I fly a lot myself. I'm sure you folks do, to reimagine the flying experience and deliver something that can be a step change, both in efficiency and comfort as well.
To follow on that, I would imagine that at least some of the mock-ups and renderings I've seen, that could be less physical windows, but the cabin opens up the opportunity for a lot of different ways to have outside views or different views within the fuselage to reimagine what the experience might be. If that's the case, you do a lot of testing with passengers in your mock-ups to try to figure out what might be the best configuration.
Yes, absolutely. So our cabin team is very adept. They've spent a lot of times in cabins themselves, decades of experience. So both drawing on their own experience, bringing through, partners, guests, getting their feedback, working with our airline partners as well has really provided a lot of great insight to us, and we value their opinions greatly. So we have a multitude of different viewpoints, whether it's flight crews we've brought through, pilots we've brought through, airline folks that we brought through, customer experience experts that we brought through as well. So we get a lot of different perspectives and insights, and all of that really helps us to formulate the strategy that we're using with the cabin, how we lay it out, how we look at different amenities or seat types or overhead compartment layouts. So we are constantly taking feedback, evolving the cabin and the product. We like to say that it's not just a mock-up, it's actually a lab, because we're constantly moving it around and trying new things and ultimately trying to accomplish, the best balance of comfort and operational efficiency within the aircraft as well.
I was thinking earlier, so every flight you come back from, you probably have new ideas about what you think you should change or improve in the cabin experience, right?
Yeah, I've become quite the critic when I'm on a tube and wing aircraft today. I'm obviously a manufacturing person, so I'll always look at, the different types of fastening methods that they use or seating arrangements or how they're connecting different parts or securing panels. It's been really eye-opening for me, because before I came into the aircraft industry, I was just like anyone else from the flying public. I just want to sit in my seat, get to where I'm going and get off the plane. But you gain a lot of insight working on aircraft, and especially something that's as game-changing as the BWB, into what some of the deficiencies in the current market are today and how we go and solve those problems with our product in the future.
I was thinking about that as a manufacturing person. The construction is vastly different, right? Between a tube and wing and a blended wing, right? Because it seems like in the tube and wing, the components are all separate and then built on top of each other. And the blended wing is very different, right?
Really, the difference is focused on the center body, right? Which is the kind of triangular shaped fuselage section. The nose, the aft section, and the outboard wings are pretty close to like a nominal construction or design. So can use existing materials and methods that are in the industry today. And I'm sure we'll get into this more in depth. But we have an opportunity to leverage all of the modern technology that's come out through, it's not really a digital transformation for us. We are digitally born, right? So we can do a lot of advanced automation, advanced design, simulation, model-based systems engineering. And it really allows us to take a new approach to building aircraft without having to leverage a ton of new or novel or unproven methods of construction. Also, we have a great opportunity here to re-examine the way that maintenance is done. I myself and our head of customer success have spent a lot of time crawling around in tight spaces, whether it's in rockets or airplanes. So we're certainly very cognizant of what it takes to maintain and sustain these aircraft in the field. So really kind of soup to nuts, we're looking at a new approach to the aircraft, considering everything from maintenance, operations, manufacturing, so on and so forth, and being able to take lessons learned from the tube and wing aircraft manufacturing industry and help to avoid some of those challenges in our aircraft.
Tim, do you think that JetZero is a completely new company, obviously extremely experienced people, but it gives you the opportunity to rethink not only the design, but also the manufacturing? Will you tend to be more vertically integrated? That means taking more responsibility of internal capabilities rather than accessing your tier 1 and tier 2 suppliers like Airbus or Boeing had done with the 787. Is that a competitive advantage or a strategy for you all?
Not necessarily. Vertical integration is something I have a lot of experience with from my past in the space business. But JetZero, one of the things that attracted me to the company is that they've taken a really low risk approach to producing this aircraft, which is the shape is the only thing that's new. I always like to make the joke that when I came here, my friends from the space industry were asking like, is it supersonic or hypersonic, or does it like transform into something? No, it's a regular Part 25 aircraft that uses today's gates, flies at similar speeds, similar altitudes. And really, we've focused the risk and the challenge in the manufacturing of the center body of the aircraft. Everything else, from the engines to the actuation systems to the environmental control systems, flight computers, are all being procured from tier 1 partners and are flying on certified aircraft today or certified themselves from the FAA at about a TRL 9. So we've really taken a de-risking approach where we're using existing engines, existing components that are certified and flying today, and centralizing our manufacturing focus on the center body and the actual airframe itself.
You mentioned the FAA. Are there different or anything new there in terms of regulatory compliance or codes that you need to meet?
No, so we plan to meet Part 25 as it's written today. This is before my time, but when we had our initial discussion with the FAA, they were grateful that this is a Part 25 aircraft and they have a playbook for it. It's not some newer novel technology like some other types of aircraft that are out there. And, we have regular meetings with the FAA. We have a lot of folks that work at JetZero, both on our advisory board and our full-time employees that have taken Part 25 aircraft all the way through testing and certification. So we feel very confidently that we'll be able to meet Part 25 and existing regulations as they're written today. We most recently brought onto our advisory board as well, Steve Dixon, who is a former administrator of the FAA. So we have a lot of great relationships, both with the FAA, with our advisory board, and partners that we feel will enable us ultimately to be successful in our certification effort for this aircraft.
The question on manufacturing, you're a new venture. You need to create a culture that's both agile and nimble, but then you're doing something incredibly hard of making an aircraft. How do you balance the being a new venture versus making sure that you were doing the things that need to be done to produce something that is extremely reliable and high quality?
As we're in the development phase for the aircraft, we're further along on the demonstrator program. But as far as it relates to the production aircraft, in the development realm, we have a subscale program that we run as well, where we're producing vehicles of various subscale sizes that ultimately help us to do rapid iteration and testing, both on smaller aircraft sizes, so we can rapidly produce new units and test out different configurations or flight controls or anything like that, and larger sizes that help us to correlate it directly with the aerodynamic performance of the full-sized aircraft. So we're able to do a lot of rapid iteration and testing, which is obviously coming from SpaceX, very near and dear to my heart. Build things, test them, learn fast while the stakes are low. And so in the development phase, we have a lot of innovation between our subscale program, the way we're looking at systems, the way we're looking at cabin layout, structures and manufacturing, factory layout. And we can achieve all that now and get that ironed out so that when we ultimately go to seek certification, then we have a dialed in process, procedures, so on and so forth, that lend themselves to achieving a type certificate and concurrently a production certificate for the aircraft long term as well. So it's really, while we're in the development phase, we can incorporate a lot of innovation and testing and trialing out these different types of components or configurations. And then eventually, we go through multiple design reviews, just like any other aerospace program, and lock down the design. And then we move on to the manufacturing of the aircraft. So I think it's a balancing of incorporating technologies that lend a lot of benefits, whether it's efficiency or safety or reliability, while also balancing that with the risk associated with developing new technologies or bringing things all the way through certification. So we're constantly evaluating the risk, the implications of different technologies that we're choosing for the airframe, and also testing out a lot of system architecture in our subscale program to de-risk it as well.
So I understand from your website as well in the video that you actually have prototype planes that you've been flying over the Mojave Desert. I'm sure it's great for testing, but does that scale as you go to a larger airframe?
Yes, absolutely. So we use a few aerodynamic techniques that our founder, Mark Page, and some of the others on the team have developed. But basically, with the subscale program that we're working, we can correlate that data directly with the full-sized aircraft. So we know that we're on the right track with different configurations or components that we're using. And we know that ultimately the design that we're producing, both for the demonstrator and the production aircraft, can draw on those lessons learned, and we can correlate that data with the full-sized aircraft as well. So it's been a really great learning opportunity for us to be able to iterate rapidly, like I said, while the stakes are low, while ultimately tying that data to the full-sized aircraft that we're producing. So just to keep both the programs straight as well, we're currently working under a contract from the Air Force to deliver a demonstrator unit in 2027. So first flight is targeted for 2027. We're working in partnership with Scaled Composites, which is a subsidiary of Northrop Grumman and really is the best place in the world to go to build a prototype aircraft. And then the production aircraft that we're working on concurrently is targeting an entry into service in 2030. So we've been drawing a lot of lessons learned from our subscale program. We'll learn from our demonstrator program and testing as well. And we'll incorporate all that learning into our production program.
And the demonstrator will be full size?
Yes.
Quick question. How much has advancements in digital design technology and simulation, additive manufacturing been able to help you do what you're doing much faster?
Great question. We recently announced we signed an MOU with a strategic partnership with Siemens. And really, I've been familiar with Siemens digital tools for many years now, having used them at a few different companies. But it really has enabled us to do all the way from the design phase. We can use advanced CFD and simulation tools to analyze different aerodynamic configurations rapidly, much faster than was done previously or is done, typically with like more antiquated methods. Also, we're able to do model-based systems engineering and have everything be model-based from our suppliers all the way through the aircraft so that we have a digital twin of the aircraft, both as we're building it in the digital realm and CAD modeling it, so on and so forth, and simulating it, but even all the way through once we produce aircraft, having a digital twin for every single unit that we produce, which gives us great insights and traceability and helps with reliability as well. Moving on from design, which also using different products like PLM allows us to collaborate. We have a lot of on-site staff and then some remote staff. So really having this digital environment that everybody can work on concurrently has helped us to be more efficient, not having to email drawings back and forth or anything like that, worry about producing paper drawings. So all of that's been really great for the design section. And then I like to say that we have the benefit of building this aircraft in a year that starts in a 20 and not a 19. So we can leverage all of the amazing manufacturing technology as well, whether it's automation, Internet of Things, connecting everything from smart building controls, electrification into the production line so that you really have, I think of it as like a digital hive mind of a factory that produces aircraft. But even beyond that, some of the amazing simulation tools that relate to manufacturing, like Plant Sim or Process Sim, NX Line Designer, allow us to visualize and analyze full rate production before we even put a shovel in the ground and break ground on the actual production facility. So I think all of these things have enabled us ultimately to collaborate better, to move faster, to iterate faster, and to save a lot of money and time on the back end as well as it relates to factory planning. So it's been amazing to leverage the Siemens platform for us of having all these interconnected tools that help us to accelerate.
That's amazing. So that is the true definition of a digital twin. Then you pretty much have a digital representation of every aspect of your design and manufacturing process being set up.
Absolutely. And a digital thread that connects everything from the design realm through manufacturing, through sustainment, even plugging into the actual smart infrastructure and building controls of the facility as well. So I'm excited. We've already been able to leverage digital technology extremely effectively. And I'm really looking forward to seeing this production facility come to life with all these different interconnected digital threads as well.
I was going to ask you about the NASA relationship and what that entails.
So NASA has been an amazing proponent of BWB. Like I said at the top, they've invested about $1 billion into BWB research over the years. They are part of our demonstrator program. They sit in on all the design reviews. They give us great feedback. And we also work closely with NASA Langley on some of the structures manufacturing technology as well. So we have the benefit, we're leveraging some amazing lessons learned from prior projects that focused on stitched resin infused composites. But not only are we just reading papers or whatever we can find on Google, we actually are working with the folks that developed that technology originally as well. So we get a lot of great insight and tribal knowledge beyond just what may be immediately available from an internet search. And NASA has been an amazing partner for us on our aircraft program.
You're located in Southern California, which has a long history of aviation and aerospace innovation. What is it like being an ecosystem there? With also many startups, it's a very vibrant place, SpaceX and many others.
We love being here. I mean, like I said, as I'm talking, you can probably hear a little background noise of planes taking off and arriving. So it's amazing. And it really gets us in the mindset of being a world-class aircraft company. It's also been excellent for us to be able to leverage the experience that's available here in the Long Beach area, from some of the legacy companies that either are still here or used to be here. We could basically throw a rock and hit the old McDonnell Douglas manufacturing facilities here. So I think it's really inspirational. There's a lot of amazing talent that's available here. And we've also found a great partner in the city of Long Beach with this facility, even helping us out with doing some testing out on our apron or closed taxiways or things like that. So it's a great environment for us currently. Right now, it's really helped us to find a home here and do all the intricate design work that's required as we've been looking for our long-term production site.
Tim, you have an amazing background in history working with some pretty innovative companies along the way, SpaceX and Launcher and Vast and now you're at JetZero. So I always like to ask my guests if they have any words of wisdom, advice for an aspiring entrepreneur or somebody who's looking to start their own company. What would you tell them?
I would say that urgency and accountability, I talk about this a lot, are two of the most important aspects to have for an entrepreneur or a leader, entrepreneurial leadership within a business. Always having a high sense of urgency. Some people refer to as a maniacal sense of urgency, where you're not just firing off an email and you wait 2 weeks to hear back. You're picking up the phone, you're thinking of things in seconds, minutes, and hours, not days. And you're really striving to maximize the amount of progress that you get out of the time that you're spending. In addition, accountability is huge. You should always know who's responsible for things. People should practice extreme ownership. A wise person that I've worked for in my career used to say, if you know about it, it's your problem. And I really try to live my life that way, and also would encourage any aspiring entrepreneurs to live that way, which is to always take responsibility for things, always identify who is directly responsible for things, and always drive that accountability into the organization overall. Beyond that, I would recommend finding partners that align with your vision, embracing digital tools early, right? You don't want to get so far down the road that it's like trying to turn a giant ship. You want to be agile, and investing in scalable hardware and software solutions that will grow with you as you grow as well. So I think that's some of the most relevant advice that I can provide to any aspiring entrepreneurs.
So if you were going to hire a new aerospace engineer or electrical engineer or whatever will fill the need, what kind of skills are you looking for in those new hires that are coming out of schools?
Beyond just the baseline skills of having CAD experience, PLM experience, those are really important. And, having demonstrated success in their academic careers of working on challenging projects or solving problems. We really look for the ability to practice first principles thinking, to not get stuck in analysis paralysis, to be able to really boil down a problem to its base parts and work on a solution for it, to not be afraid to ask questions that may seem simple on their face, but oftentimes can uncover things that maybe were not immediately evident to folks that were thinking in a more complex fashion. A resilient attitude, ownership, accountability, and a high sense of urgency and just enthusiasm about the product and the project overall. So there's a lot of different aspects that you look for in a successful engineer on an aerospace program. But I would say those are some of the most important things: is taking ownership, driving hard, having creative thinking about things through the lens of first principles, and ultimately being dedicated to the mission that they're working on and wanting to deliver this new product, this new technology to the market.
Great characteristics and advice for our college listeners.
Yeah, sense of humor is always good too when you work at a startup.
Well, I think your advice before too was relevant, whether it's a startup company or a large company, right? Taking accountability and having a sense of urgency when you have tasks in front of you, right? So I think that's a huge positive attribute that people can bring to the table. Tim, did you have any questions for us as Siemens or Northeastern University?
What do you guys love about the kind of new reshoring boom, the opportunity to digitize from your own backgrounds? What are you most excited about, or what are you looking forward to?
It's just amazing to me to see the level of technology and innovation that's happening there. I mean, what JetZero is working on, I just can't even imagine that taking place 20 years ago. And the level of maturity and advancement that I see occurring in these startup companies, and like you talked about, adopting digital tools early and digitalizing every part of the process along the way. And that's been a massive advancement, I think, in the ability for companies to scale and grow and really mature quickly as an organization and get their products to market a lot quicker. And that's kind of what I saw like in the last 10 years, especially, is that companies were working with solutions and tools that really weren't aligned with what the complexity or what their corporate company goals were, their startup goals were, right? And so they would run into these brick walls and they'd have to kind of start over again, or they wouldn't get the first minimum viable product to when they wanted to. And so it created a lot of disruption. Whereas I see startup companies today really starting with that in mind, which is amazing, right? So I talked to a lot of startup companies who are looking at adopting digital tools from the get-go.
I think it's super exciting that you're working on US-based manufacturing. As someone started my career in manufacturing in the US in the auto industry, I think there's nothing personally more satisfying than see a large-scale operation that's producing things every day. But the trickle-down effect is really incredible when you think about a local facility, because you have service providers, you have technicians that are coming into the organization, you have the mom and pop food truck that's across the street that benefits from engineers going to lunch. There's a lot bigger footprint of what you're doing in Long Beach, California, than what just an office building might do that's selling insurance, for example. So I just think it's a great space, and I'm really excited over the next 10 to 15 years of rethinking what domestic manufacturing is and how we can propagate it and make it better.
Yeah, absolutely. I wholeheartedly agree. And one of the things that we've talked about publicly in partnership with Siemens is the construction of this factory of the future to produce aircraft, right? Truly a 21st century smart digital hive mind factory that we're really excited to get off the ground and be able to leverage all the innovation, whether it's software or hardware that's available on the Siemens platform in order for us to accelerate our pace of innovation, manufacture better, faster, cheaper, more reliably, and ultimately deliver a lot of value both for the community where we locate the production facility, but also the country overall.
Excellent. I think we're going to wrap it up. I want to thank you, Tim, very, very much for sharing your insights and the future of aviation. I can't wait to see Jet Zero in the coming years, and we'll look forward to 2027 when you have your demonstrator flight. If people want to find out more about Jet Zero, do you want to give us your website?
It's actually a killer website domain. It's JetZero, JETZERO.aero, AERO. You can also go to our LinkedIn page. There's some great information available about the Jet Zero and Siemens partnership on the Siemens website.
Yeah, I was poking around. There is some really nice stuff, some really cool stuff out there.
And I can't wait to fly on one for the first time.
Me too. I think everybody that comes here, we like to say, if we can just get you here, we'll make a believer out of you. So everybody that leaves here, they skip out and they're really excited about it.
Next time I'm in Southern California, I'll make sure to stop by as well. Tucker, thanks, as always, thanks for joining us today. I'll look forward to our podcasts in the future. And to our listeners, thanks for tuning into Siemens Startup Podcast. If you enjoyed today's discussion, be sure to subscribe, leave a review, and stay connected with us. You can learn more about Jet Zero at jetzero.aero and explore Siemens startup programs at www.siemens.com/startups.software.solutions. Thanks for listening, and remember, innovation has no boundaries.